Hello students, in my this video we discuss limit of a function does not exist. First we discuss theorem, next we discuss examples of limit of function does not exist. Okay beta. First Cauchy criteria beta. Limit x tends to a fx equal to L given epsilon greater than 0 however small there is a delta positive real number such that fx1 minus fx2 less than epsilon for 0 less than x1 minus a less than delta 0 less than x2 minus a the modulus less than delta. Beta x1 x2 lies between neighborhood of a. बेटा वेरी वेरी इंपॉर्टेंट पॉइंट बेटा x1 x2 किस लाई करता है नेबरहुड ऑफ a ਦੇ ਵਿੱਚ जो लिमिट x tends to a in the neighborhood of a x1 x2 lies. So beta first we prove this. Beta limit given अपन x tends to a fx okay equal to L. So by definition fx minus L less than epsilon for 0 less than x minus a the modulus less than delta. Beta is the meaning here x belongs to a minus delta to a plus delta. So x1 x2 lies between neighborhood of this. So we write x beta is the which lie करता है x1 x2 भी इसके which lie करता है. So we write fx1 minus L less than epsilon for 0 less than x1 minus a less than delta and fx2 minus L less than epsilon for 0 less than x2 minus a less than delta. Okay, we prove this. So fx1 minus fx2. Okay, fx1 beta we have minus L plus L. Okay, by beta triangular inequality fx1 minus L plus L minus fx2. We write fx1 minus L plus fx2 minus L. Okay, beta this one is less than epsilon less than epsilon. So we prove less than epsilon prove करना बेटा. So we take epsilon by 2 क्योंकि ये वैल्यू है स्मॉलर होनी चाहिए. So we take epsilon by 2 less than epsilon, no problem. So this one equal to epsilon. So we prove fx1 minus fx2 less than epsilon if limit exists. Beta then fx1 minus fx2 less than epsilon. If we prove fx1 minus fx2, beta very very important point, greater than epsilon for 0 less than x1 minus a less than delta 0 less than x2 minus a less than delta, then we say limit x tends to a fx does not exist. Beta so we try examples beta जिसके which limit of a function does not exist. So beta एक पॉइंट ध्यान रखना बेटा x1 x2 lies in neighborhood of a. जिन्हें एग्जांपल फर्स्ट बेटा. ओके, एग्जांपल फर्स्ट की है fx इक्वल टू मॉडुलस x अपॉन x. प्रूव दैट लिमिट x टेंड्स टू 0 fx does not exist. So beta we use this theorem, this result. We prove this one greater than epsilon, then the limit does not exist. Okay, okay beta. So let epsilon greater than 0. Okay, take epsilon lies between, क्योंकि एप्सिलॉन की एक पॉजिटिव क्वांटिटी है वेरी स्मॉल 1/2 1/3 0 तो 1/2 है बेटा. सो अपनी चॉइस है 0 लेस देन एप्सिलॉन लेस देन 1 भी रख सकते हैं इसको. ओके बेटा क्योंकि एप्सिलॉन की है वेरी स्मॉल पॉजिटिव क्वांटिटी, सो वी टेक epsilon lies between 0 and 1 ਦੇ ਵਿੱਚ then x1 x2 belongs to neighborhood of 0 किस लाई करेगा बेटा neighborhood of 0 we take x1 in left neighborhood चलाई कर देखो बेटा x1 belongs to 0 minus delta to 0 and let x2 belongs to right neighborhood 0 to 0 plus delta बेटा your choice x1 in right neighborhood x2 in left neighborhood बेटा because we say in this theorem x1 x2 belongs to neighborhood of a so in this one x1 x2 belongs to neighborhood of 0 okay बेटा so fx1 minus 0 sorry fx1 minus fx2 okay बेटा fx किस दे इक्वल है पुत्र x1 modulus upon x1 and this one equal to x2 the modulus upon x2 okay बेटा clear x1 belongs to left neighborhood we know that value of modulus beta value of modulus beta we know that modulus x have two values x greater than 0 minus x less than 0 so beta x1 lies between beta देखो 0 तो less वाली values है which so we say fx1 minus fx2 this one equal to minus x1 upon x1 x2 lies greater than 0 beta positive so minus in right neighborhood x2 upon x2 we have minus 1 so we have 2 minus 2 the modulus is 2 is greater than 1 and देखो बेटा epsilon less than 1 we write 1 greater than epsilon for 0 less than x1 minus 0 less than delta 0 less than x2 minus 0 less than delta so fx1 minus fx2 greater than epsilon so we say this one limit does not exist beta next example देखो ना next example prove that limit x tends to 0 sin 1 by x does not exist so beta first let epsilon greater than 0 and epsilon lies between 0 and 1 and x1 x2 belongs to neighborhood of 0 so we take x1 belongs to 0 minus delta to 0 and x2 belongs to 0 to 0 plus delta okay let take x1 equal to 1 upon pi beta negative because beta 1 upon pi क्यों चूज किया बेटा 1 by x है so 1 by x equal to कितना बन जाएगा बेटा sin pi so we have x1 equal to 1 upon pi and this one is a negative and less than 0 because pi is 22 by 7 by 22 lies the negative values okay and x2 2 upon pi this one is a 14 upon 22 7 by 11 greater than x so we choose this one value okay 1 upon pi 2 upon pi because put at this one sin pi and sin pi by 2 both value know so we calculate this fx1 minus fx2 okay beta this one equal to sin 1 by x1 minus sin 1 by x2 we have sin minus pi minus sin pi by 2 this one equal to sin minus pi beta 1 by x okay minus sin pi by 2 sin pi 0 बेटा, sin pi by 2, sin minus theta minus sin theta, sin pi किधर इक्वल हो गया बेटा 0, sin pi by 2 1, 0 minus 1 1, बेटा p choose epsilon less than 1, so 1 greater than epsilon. So because epsilon is a very small quantity, so fx1 minus fx2 greater than epsilon for 0 less than x1 minus 0 less than delta, 0 less than x2 minus 2, x2 minus 0 less than delta. Okay beta. Next example beta. Example third. Limit, prove that limit x tends to 2 1 upon x minus 2 does not exist. Beta, third example, this one is a does not exist. Okay beta. Let epsilon greater than 0 and lies between 0 and 1. Okay beta. This one is lies between 0 and 1. Then x1 x2 belongs to neighborhood of 2. Let x1 belongs to 2 minus delta 2 2 and x2 belongs to 2 to 2 plus delta. Okay beta. Left related to neighborhood, right related to neighborhood. Then x1 x2, take x1 equal to, okay beta 2 to less than 2 minus 1 by n, n is a natural number. Okay, 2 तो थोड़ी वैल्यू का जितना ग्रेटर होएगा बेटा only very small change in lies between this one and x2. Okay, we take x2, 2 plus 2 by n. Okay, we take 2 plus 1 by 2n क्योंकि वैल्यू स्मॉल लेनी है बेटा आपको 1 by 2n. n is a natural. Okay beta, small value choose. So beta fx1 minus fx2. Okay. This one equal to fx1 1 upon x1 minus 2 minus 1 by x2 minus 2. So 1 by x1 2 minus 1 by n minus 2 minus 2 plus 1 by 2n minus 2. Okay, this. We have minus n minus 2n. This one equal to 3n. n is greater than equal to 1 because natural number. This one is greater than equal to 3 because n the value minimum 1 होनी है बेटा. So 3 greater than 1 greater than epsilon. 4 0 less than x1 minus 2 less than delta. So beta key आ गया does not exist. So last beta example number 4. Example number 4. Limit, prove that limit x tends to minus 5 by 2, x tends to minus 5 by 2 into 1 upon 2x plus 5 does not exist. Okay beta, a prove करना 2x plus 5 does not exist. Let epsilon greater than 0 put, epsilon की रख ले greater than 0 and epsilon lies between 0 and 1. Take x1 x2 belongs to neighborhood of minus 5 by 2. Okay, let x1 belongs to minus 5 by 2 minus delta minus 5 by 2 and x2 belongs to minus 5 by 2 minus 5 by 2 plus delta. x1 lies between left neighborhood and x2 lies between right neighborhood. So we take fx1 minus fx2. sorry, x1 the value. So x1 beta we write minus 5 by 2 minus 1 by n, and n की है बेटा नेचुरल नंबर, माइनस 5 by 2 plus 1 by 2n. Okay बेटा, where n is a natural number. So we have fx1 minus fx2. Okay, fx1 1 by 2x1 plus 5 minus 1 by 2x2 plus 5. 1 by 2x1, 2 ना 2 कैंसिल हो जाएगा बेटा, x1 की वैल्यू 5 ना 5, देखो 2 इंटू माइनस 5 by 2 माइनस 1 by n प्लस 5 माइनस 1 upon 2 minus 5 by 2 plus 1 by 2n plus 5. Okay, this one is equal to 1 upon 2 na 2 minus 5 minus 2yn plus 5. Okay, minus 1 upon minus 5 plus 1 by n plus 5. This. We have minus n by 2 minus n. This one equal to 3n by 2. N is greater than equal to 1. So greater than equal to 3 by 2 greater than 1 greater than epsilon. For x1 plus 5 by 2 less than delta. For 0 less than and 0 less than x2 plus 5 by 2 less than delta. So beta this one is a does not exist. So beta example see limit of a function does not, examples of limit of a function does not exist. So beta is the exercise a question try karna beta. Thank you very much.